Hello and welcome to TikTok Tour. In this video, we're going to take a look at how to solve quadratic equations. There are 4 key ways to do so, which include factoring, completing the square, and then solving for x thereafter, using the quadratic formula, using a graphing calculator, or graphing it by hand. But typically we use a graphing calculator like Desmos.com or a TI-84 to check our work. But the first 3 are majorly the algebraic methods of solving quadratic equations. Let's take a look at method number 1 for this video through these 6 examples. If you'd like, you can pause the video here before we get into going through the solutions for each of them separately. Okay, let's take a look at example number 1. In this case, it's special because, as you'll notice, there's no c term or constant to this equation. So that actually makes our life a little bit easier when we're trying to solve this equation. Because what we can do is we can do common factoring first, and that should always be the first thing that you check for. Whenever you're factoring, you should always start by checking if there is some sort of common factor that can be pulled outside, and so that you have some simplified factor left that you then have to deal with, which in this case, if you take a look, are 2 and -6, so the coefficients are both even numbers, so they can divide by 2. And both of our terms have the variable x in it, so we can pull that outside. And what's left is x from the first term and -3 from the second term. And it's already in factored form with just that one step, which is really great because now we can set each factor equal to 0 and solve for what values of x will allow for the right side to equal to 0, just like the left side. So one factor is x, which as it is, you can equal to 0, and when it does, then left side equals right side. And the second factor is x minus 3, which if we set that equal to 0 and we solve, then we get x minus 3 equals to 0, and when we solve, we get x equals to 3. Those are our 2 solutions to this equation. So if there's no c term, i.e. there's no plus some sort of constant like that or something, then we are good. We can just go ahead and factor whatever is common to both terms, and we reach factored form. For our next example, it's a simple trinomial because the coefficient of x squared is 1, which we don't typically write, but it is there. And in that case, in order to factor, we just need to find 2 numbers that multiply to equal to -12, so the last term or the c term, and add to the middle value, which is 1. Again, if you don't see a coefficient beside the variable, then you can assume that there is a 1 there that's invisible. So in order to figure this out, we can write out what the factors of 12 are, which are 1, 12, 3, and 4, 2, and 6, and that's about it. Now, because our last term is negative, that would mean that one of our 2 numbers has to be negative, so that when you multiply, you end up with a negative value. But since the middle term is positive, that would mean that the smaller of the 2 values has to be negative. So these are all of our smaller values. And let's see, 12 minus 1 won't equal to 1, so that won't work. 6 minus 2 will equal to 4, that won't work. But 4 minus 3 equals +1, and 4 times -3 is -12. So this pair works well for our purposes. So we can write the factored form as x minus 3, x plus 4. And just like before, we can set the factors equal to 0. So x minus 3 and x plus 4, when set to equal to 0, solve to equal x equals 3 and x equals -4. Okay, so we have our two solutions to this equation. Now let's change things up a little bit. Here's our third example, which looks a little different because now we're missing the b term. In case you're wondering what I'm referring to whenever I say a term, b term, c term, that's using the standard form of the equation. We have y equals ax squared plus bx plus c. So whenever the equation or expression is given in standard form, then the coefficient of x squared is a, for x it's b, and the constant is c. Typically, that's how it is. So that's just a side explanation. Okay, so here we're missing the middle term, and we can use the same methods as before to factor. So if you've learned about decomposition or some other methods, you could use those. But there's something else that I noticed that's special here. The 4x squared is a perfect square, and so is just the 1. And when you have two perfect squares that are being subtracted, we call that a difference of squares. So difference, oops. Looks something like this, where the factors are a plus b and a minus b. And as I said, you can go the long way around. You could instead write this equation like this. So you could have 4x squared plus 0x minus 1, and then factor according to whichever method you'd like, and it will work out just the same. But if you recognize that this is a difference of squares, then you can save yourself some time by remembering this form of the equivalence, and you can take the square root of the first and last term in your binomial and find out what the a and b are in this case, and just write out the factors. So for our particular example, I'm going to rewrite down here 4x squared minus 1. The square root of 4 is 2, and the square root of x squared is x. So that's our first term. And for the second one, we have just 1 squared equals to 1. So when we're comparing back to this form of the equation, we should recognize that a equals to 2x in this case, and b equals to 1. These aren't things that you typically have to write down. It's more just I'm trying to show you through written form as well what I'm talking through, but you don't have to write all these steps down. It's actually pretty quick. You could generally just jump from your original equation directly to here after you recognize what the square root values are for your perfect squares. So our first factor is 2x plus 1, and the second factor is 2x minus 1. And to solve for our values, again, we set the factors equal to 0, so we have 2x plus 1, 2x minus 1. So we'll first take the positive 1 to the other side by subtracting both sides by 1. And then we'll divide both sides by 2. So we get x equals -1 over 2. Next, we will add 1 to both sides, so we get 2x equals to 1. And then we divide by 2, so we get x equals to 1/2. And there are our two solutions. Pretty useful to know what a difference of squares is. Here's the full solution. And so just always remembering what this form is can be really helpful to save you some time. Here's our next example. So this is a complex trinomial. There's no general shortcut here. We are just going to have to work through what the factors would be. So let's explore a different method of factoring for this one. Let's use the box method. In this case, for the box method, we need to find two numbers. So the general process is the same as decomposition or some other methods you may have seen, but then it'll differ with the box. So two numbers that multiply to equal to the product of A and C, and two numbers that add to equal to B. In this case, our B term is 6. So I'm gonna replace the B with 6 here. And the product of A and C is 1 times 9, which is 9. So let's explore the factors of 9. We have 1 and 9, 3 and 3. And since everything is positive, we're keeping our factors of 9 positive as well. So which values add up to 6? 1 and 9 don't, so we'll cross those out. But 3 and 3 work out to add to 6. So that's great. We found our values. So now, in the top left box, we always write down our leading coefficient and variable. So we have 9x squared that always goes here. And then the C term goes at the bottom right. And we split the middle term and place it in either the top right or the bottom left boxes. It doesn't matter which one goes where, they will work out to the same answer no matter what. But the top left is always the one that has the x squared in it, and the bottom right is always your C term or your constant. Okay, so we have 3x here and 3x here. Now, for each column and each row, we're going to take a look at what the common factors are. So let's start with the first column, or the left column. The coefficients both divide by 3. The variables both divide by x. Now for the second column. The values don't have anything in common, so we're going to say that it's 1. They can both divide by 1. Now looking across the top row, we see that both terms can divide by 3, and they both divide by x. So we have 3x. And the terms at the bottom have nothing in common, so we're going to say plus 1 again. And now we have our factors. Turns out that this is a perfect square trinomial. So we can set our factor equal to 0, just like usual, and solve. Subtract 1 from both sides, divide by 3, and we get that x equals to -1/3 is the sole or only solution to this equation. Here's our next example. Again, complex trinomial. There is nothing common to our 3 terms, so no common factor. And again, we will use the box method just to get a little more practice with it. But I can also show this using the butterfly method right after. So I'll go a little quicker this time. Here's our box. We already know we're going to put the 6x squared and -5 here, so we'll do that right now. This time, we need two numbers that multiply to equal to 6 times negative 5, which makes negative 30, and two numbers that add to equal to negative 13. The factors of negative 30 are 1, 30, 2, 15, 3, 10. And the values that work in this case are 15 and 2, because we need to subtract so that we get the final term, so the one that multiplies, it needs to have one negative and one positive to end up with a negative value overall. So that's why even though 10 and 3 could possibly subtract if they were both negative to equal to negative 13, that won't work in this case because we only need one of them to be negative. And since the value overall is, or sorry, the one that we're adding to is negative, that means that the larger of the two values has to be negative. So 2 minus 15, or negative 15 plus 2 makes negative 13, and negative 15 times 2 gives us negative 30. So let's add that to our box, negative 15x and positive 2x, and let's start looking at what's common. Let's start with the column on the left. We have 2x, and for the column on the right, the coefficients both divide by negative 5. Now looking across the top row, we have 3x, and the bottom row, nothing seems to be common, so we're going to say plus 1. And you can always, once you're done factoring, the really great thing is you can always double check your work by distributing and seeing that it multiplies out to the original expression that you were given. If you'd like, you can skip this part, but I'm going to give you a quick little explanation into how to use a different method to factor, just in case you're interested. This is the butterfly method, or so I've been told. And in this case, you explore the factors and you build some intuition towards how to work with this, just by listing them out right below the first and last terms. So if we take a look at our factors of 1 and 6 and 2 and 3, those are the factors of the first coefficient, and the last value, the C term, has factors of 1 and 5. One of them will have to end up being negative, but we'll see what that is. So the way this works is once you've listed out your factors, you have to find the combination of values that when you multiply across like this, and then you add or subtract those product values, they should equal to the middle term. So for example, we have 1 times 5 makes 5, and 1 times 6 makes 6. And then I have to ask myself, is there any way that 5 and 6 could add or subtract to equal to negative 13? And there's no possible way. So this isn't going to work. And even if I had changed the order of this, if I change it to 6 and 1 instead of 1 and 6, and now I multiply, then I get 30 for 6 times 5 and 1 for 1 times 1. And 30 and 1 can also not add or subtract to equal to negative 13. So we're going to get rid of these factors, or you could just cross them out on your paper. Now let's check what would happen if we had 2 times 5, that's 10, and 3 times 1. Those, again, just like we saw over here, if we had 10 and 3, they could work if we were subtracting and we had both values being negative, but in this case, this won't work, just because one of them has to be negative, not both. So now let's switch up the order, and here we have 15 and positive 2. So that's the product, or those are like the values that we found in our previous example, and we know that's going to work because negative 15 plus 2 will give us the negative 13 that we're looking for. And in order for us to get to negative 15, the 5 has to be negative here. So what's different about the butterfly method is once you found that, then you can read your answer across your screen or your paper like this by adding in your coefficients. You read across and you see, okay, so my factors are 3x plus 1 and 2x minus 5. And now to the side, we're going to set each of our factors equal to 0. I'll use a different color to make this stand out a little bit. 3x plus 1 equals to 0 gives us x is negative 1/3. And 2x minus 5 equals to 0. Bring the 5 over, we get 2x equals to 5, and divide both sides by 2, and you get that x is equal to 5 over 2. Okay, so the solutions to question 5 are negative 1/3 and 5 over 2. Last example. This time, hopefully you'll notice that we have one common factor, which is 3. So let's start there. We'll factor out 3, and we have 4x squared minus 5x minus 6. Another complex trinomial, but we had to common factor in this case as well, so one added step. Let's go ahead and try to factor this using the butterfly method again and see how that works. So for 4, we have 1 and 4, 2 and 2. And for 6, we have 3 and 2, or 1 and 6. And let's get to trying out our combinations. So at the end of the day, we need to have one of the values on this side for whichever pair of factors we choose. One of them has to be negative to end up with a negative 6 value. And we need to subtract 2 values, one positive, one negative, to end up with negative 5. Okay, so if we multiply across here, we get 12 and positive 4, and those are not going to subtract in any way to give us negative 5. So that's not going to work. Now let's take a look at what would happen if we had 4 and 1 and 2 and 3. In this case, we have 8 and 3. And so we could make our 8 be negative. So 4 times negative 2 gives us negative 8, plus positive 3 gives us a negative 5. And let's just double check at either end if our values multiply correctly, which they should, given that we only chose pairs of factors that work. But we should double check. 1 times 4 is positive 4, great. Negative 2 times positive 3 is negative 6. So now we can write out the factored form by just reading across the screen. So we have x minus 2, 4x plus 3, and we can now solve. So we have x minus 2 equals to 0, so x equals to 2, and 4x plus 3 equals to 0, 4x equals to negative 3, or x equals to negative 3 over 4. And those are the solutions to this equation. While we're done with this set of examples overall, I can go ahead and just show you generally how to do this using the box method again, just so you have that in your toolkit, and in case that worked out really great and you're not about the butterfly method, then that's completely all right. But then this will at least allow you to check your work. Although like the answer is there, but just to walk you through the process one more time. So for 4 and negative 6, those multiply to equal to negative 24, and our middle term is negative 5. the factors of negative 24 are, or for 24 that is, are 1, 24, 2 and 12, 3 and 8, 4 and 6, and that's about it. So which of these values or pairs can subtract to equal to negative 5? Well, that is right here. If the 8 is negative, just like we saw in the previous version of the solution. So we have negative 8 plus 3 and negative 8 times 3. And we'll add those into the box. We'll add in our leading term here, which is 4x squared, and our c term, which is negative 6. Just want to select and isolate this to make it a little more clear. Okay, so across the top row, we have 4x, and the bottom row, we have positive 3, which is common. The first column, or the column on the left, we have x, and on the column, in the column on the right, we have negative 2. So the factors do match up very well to butterfly method. We have, and don't forget when you work with the box method, since you're ignoring the common factor while you're working through it, just remember to reintroduce it at the end because that is still part of the equation. And that's it. Thank you so much for watching. I hope that this was helpful. Here are all of the solutions all on one big screen. Hope this helped.